Good afternoon, everybody. My name is Wang Ye, Associate Professor in the Department of Computer Science, National University of Singapore. I'm honored to give the last keynote speech of our Computing Research Week. My talk today is about music and wearable computing for health and learning, a decade-long exploration on a neuroscience-inspired interdisciplinary approach. The title is a little long, but I would like to say this represents a long journey. These words each represent an individual discipline and possibly multiple research communities. I'm today going to talk about how to leverage neuroscience as a glue to connect the seemingly uncorrelated disciplines. I will divide my talk to 4 parts: motivation, and then the key research theme on music and wearable computing for motor functions. Then I will share my reflections, the key insights, and future directions. Finally, I will give you some advice based on a neuroscience-inspired, the deep learning-based educational model. Let me give you the motivation. What have attracted me to this particular uncharted water? I must mention NGS. It is nowadays called ISAP. It was established about 10 years ago to foster cross-disciplinary research in NUS. Roughly at the same time, I got to know a new concept called neurologic music therapy, which is very interesting to me. And the freedom after tenure allowed me to step out of my comfort zone to explore the boundary between computing, music, and healthcare. Luckily, in NUS, we have a good school of computing, conservatory of music, and 2 great medical schools. This allowed me to go to this sweet spot. Well, I got my tenure on July 1st, 2011. It is almost exactly 10 years ago. That's why I'm so pleased to give this keynote almost as an anniversary talk to reflect what I have done in the past 10 years. Basically, before my tenure, my entire research career focused on low-level audio signal processing. But afterwards, I have the flexibility and the brain, the human brain, caught my attention, and a real-world application in e-health also attracted me a lot. I was preparing my first sabbatical in Harvard Medical School. My host, Professor Gottfried Schlock, introduced 2 fundamental problems he was facing. Number 1 is about the Parkinson's disease patients, the gait training problem. 2, how to train the aphasia patients to speak again. And this is a very common phenomenon after stroke. So he asked me a simple question: can sound and music computing help? I answered, yes, let's try together, see what turns out. I was very grateful to him to teach me a lot of interesting things, including neuroplasticity and synaptic connections in our brain. Now, I could start to build a new heart, neuroscience-inspired and application-driven research program. Sound and music computing is still the core of our research program, but we ventured out to mobile and wearable computing, as well as applied machine learning. Nicely, the neuroscience served as a glue to combine all of them nicely to solve some interesting problems in real life, especially in e-health and e-learning. This hut represents what we do in the NUS Sound and Music Computing Lab. Well, now let's move on to one of the central research problems that I spent the most of my research energy in the past 10 years. That is about motor functions, human motor functions. And this involves a lot of things. The first population that I observed and worked with is Parkinson's disease patients. It has 4 major motor impairments, which result in unstable gaits and eventual falls, which are costly and very dangerous. So this problem is very difficult to solve. So far, there is no cure for Parkinson's disease. Luckily, rhythmic auditory stimulation is a clinically proven neurologic music therapy for motor rehab. Unfortunately, it is quite manpower intensive. The natural question coming to me, how can we develop the sound and music technology, music computing technology to help make this intervention accessible and affordable? So let me now move on to our core research theme in the past 10 years, music and wearable computing for motor functions. This is the framework I have developed to address this challenge. Professor Schlock and presented it to me. In this framework, I put the patient in the center, rather the clinicians. And our technology, together with the clinicians, is part of the system to help patients to recover. And the current COVID pandemic helped really make the telerehab a common practice, even in Singapore. I divided our technology solution to 2 parts. Number 1, computerized music intervention to improve patients' gait. And the natural question comes, how do we know the intervention is effective? We need scientific evidence. This brought naturally the wearable sensors into picture. We need the gait assessment to quantify the outcomes. And all this formed a closed loop solution, which is pretty nice. We have focused on 2 clusters of problems. Number 1 is sound and music computing. We developed a music search engine for gait therapy, and we also investigated the auditory tempo stability, which is a key feature to select the right music for intervention. We developed also music recommenders for the same purpose. We built also systems which can be tested with real patients. Of course, the second cluster of problem, we focused on the mobile and the wearable computing. We developed 2 systems, the Iris system and the Mana systems with 2 versions. During this journey, we explored several research communities, and I also got to know a number of world-class clinicians, neurologists, music therapists, physical therapists, etc. The very first research community that really had an immense impact or influence on my research is the International Society for Music Information Retrieval. Izmir in short. Perhaps because of my pioneering work in using sound and music computing for healthcare, I was invited to give a keynote speech in Izmir 2014. The title is Sound and Music Computing for Exercise and Rehabilitation. Luckily, in that year, our paper, Enhancing Collaborative Filtering Music Recommendation by Balancing Exploration and Exploitation, received the Best Paper Award. My student, Xinxi, was nominated for Microsoft Research Fellowship Award based on this line of research. Since then, music, health, well-being, and therapy have become a topic of interest in the Izmir research community. I've then even organized Izmir 2017 in our own campus in Suzhou to make this line of research a prominent feature in this community. I'm very grateful to my colleague, Professor Tan Tiao-Seng, to help with the local organization. This is a building of our conference venue, and this is the conference logo that Tiao-Seng helped to design. Because of my involvement in this community, people in this community invited me to Stanford CARMA, which is the Interdisciplinary Research Center, as well as the Stanford Medical School in 2016. Then in Loris Center in Holland in 2019, as well as an online keynote speech last year. As explained before, stability of music tempo is a very important issue if we want to use music for medicine, for healthcare. Then we looked at a famous music database called a Million Song Dataset. We were pretty surprised. Only 20% of the songs there have stable tempo from the beginning to the end. So this is an example to show a piece of music, regardless of how much the patients like it. If the tempo is not stable, it is dangerous to use it for medical purpose. Since it is difficult to find music that satisfies both user preference and a clinical requirement, what can we do? That's why I came up with a project called Music RxC, an automatic music composition system, which has actually several advantages for clinical applications. Basically, it's an AI-based system to generate royalty-free music for healthcare. This is a baseline model that we use to decompose a complex piece of music to several elemental components. For example, the tempo here is 145 beats per minute. Then this is the music structure. This is the beat, music beat, drum, and chords, and then bass, and the melody. And then I wanted to show you a demo and how it works. This is drum beat. Chords. Then bass. And finally, melody. Yes, now let me move on to the second cluster of research we have done, which is mobile and wearable computing. We have also explored several research communities for this line of research. Now let me explain the first project in this line of research. It is a iOS-based Rhythmic auditory cueing evaluation system for Parkinson's disease patients' gait assessment. Basically, it is just a smartphone app. This is the setup for the clinical experiment we have done in Singapore General Hospital. I wanted to show you a video demo to see how this system works.
Parkinson's disease affects approximately 1% of individuals over the age of 60, or roughly 7 million people worldwide. This number will rise sharply as society continues to age. Parkinson's disease is characterized by a number of pronounced motor impairments, including tremor, rigidity, slowness of movement, postural instability, and gait freezing. Despite more than 50 years of research, a medical cure remains elusive. However, a well-supported, evidence-based intervention for the treatment of gait impairments in Parkinson's disease is rhythmic auditory cueing. During a rhythmic auditory cueing intervention, patients attempt to synchronize their movements with an auditory cue presented either as a metronome or music with a strong, steady beat. Here, the same patient seen previously shows a dramatic improvement in his ability to walk during self-administered rhythmic auditory cueing. However, rhythmic auditory cueing interventions have not been widely adopted due to limited access to personnel, technological, and financial resources. High-quality measurement of gait performed in a clinical setting is typically performed using foot switch sensors, pressure mats, or motion capture cameras. To help scale up rhythmic auditory cueing for wider distribution, we have developed iRace, an iOS-based rhythmic auditory cueing evaluation mobile application to help quantify clinically relevant statistics associated with motor function. iRace has been designed with a number of flexible experimental settings, including the duration of each trial, the number of desired events to collect per trial, and the type of auditory cue which is delivered. The touchscreen of the mobile device is used to assess upper motor function during self-paced tapping, tapping that is synchronized to an auditory cue, tapping after the cue is removed, and tapping as rapidly as possible. The mobile device's built-in tri-axial accelerometer and gyroscope are used to assess step time and step length during walking. The device is attached to the body at the navel using a chest strap. The mobile device records movement continuously during self-paced walking, synchronization walking, and continuation walking, similar to the tapping tests. Novel machine learning-based gait analysis algorithms have been developed for iRace, including heel strike detection, step length quantification, and left versus right foot identification. The accuracy of iRace-derived gait statistics has been evaluated using concurrent validity by recording gait simultaneously with iRace, heel-mounted foot switch sensors, and a clinic-standard pressure sensor mat in a sample of 10 Parkinson's patients. Preliminary results reveal that iRace quantifies both average step time and average step length, as well as step time and step length variability, with margins of error that are acceptable for clinic use. In addition to further experimental testing in both Parkinson's patients and healthy elderly adults, future work will incorporate iRace into a cloud-based network to facilitate data collection and data sharing, and provide integration with commercially available streaming music services to dramatically expand the range of candidate rhythmic auditory cueing stimuli. We hope that this combination of portability, accuracy, scalability, and customizability will lead to better characterization and, ultimately, treatment of motor impairments in Parkinson's disease.
I hope you have enjoyed this short video. This is my first truly multidisciplinary research project at NUS, involving computer scientists, experimental psychologists, neurologists, and rehabilitation doctors. After this project, we started to examine the pros and cons of the mobile phone-based solution. The pros is obvious. Off-the-shelf hardware, mature development environment, and both sound and IMU processing can be done on the same devices. But there are also some problems with these smartphone solutions. The most important thing is the limitations on the placement. As you can see, it will be difficult to put a smartphone onto patients' shoes. Therefore, we tried to actually take the sensors out of the phone and to form a small form factor. We tried to do a product survey from the very cheap commercial products to slightly more expensive clinical gait assessment device to a really expensive assessment device like a Gatoride, which cost more than 60K Singapore dollar. But it is actually necessary to use it as a ground truth. We thought there is a gap between the commercial fitness tracker and clinical gait devices. This is the motivation for us to develop our own mana sensors involving 2 PhD students, Sengao and Boyd. We can, of course, list some advantages of our solution, but I must confess that I've completely underestimated the challenges along the journey of developing hardware sensors in a computer science department. This is the placement of 5 sensors for our clinical trial. This is the clinical experiment setup. This team includes myself, 2 of my PhD students in computer science, and Professor Wang Jian, and 2 medical doctoral students. This is a Parkinson's disease patient. This is the entire setup in the room for the experiment. We did not have even get right devices available at that time. Therefore, we developed our own computer vision-based gait assessment system to serve as a ground truth. Here is a healthy adult to go through this experiment. Here is a Parkinson's disease patient. And you can see the striking difference between these 2 workers. Please pay attention. Now it's freezing, a symptom of Parkinson's disease. We collected data, and the raw data, unfortunately, is not very useful for the clinicians. Therefore, we must compute clinical outcome measures which make sense to clinicians. We tried to synchronize the patient's gait with music. Then we have to compute the music beats. We use the music beat to entrain the gait. So this is a visualization to show the step time intervals. We can have more data and compute the clinical outcome measure. For example, the coefficients of variance, and we can compute using this equation here. And get a magic number here for the healthy subject. Of course, this number does not necessarily make a lot of sense to us. But when we compare this number between the healthy subjects with Parkinson's disease patients, you can see the clear difference here. There are other important outcome measures like step length, step width. It is challenging to compute them with our MANA WANG sensors. That's why we were motivated to develop the MANA 2. We published our paper, MANA 1 paper, in this research community on computers and accessibility. And we developed further our MANA 2 including actually this UWB sensors. We published the results in UBCOM 2019. Now, I briefly covered the research effort I've done in the past 10 years' time. I would like to give you guys some reflections, key insights, and show our future directions. What have we learned from this exploration? The bar for such interdisciplinary research is very high. Clinicians, students with the right mindset and skills, as well as large grants, all must be in place. Passion alone is insufficient. Second, a lot of overhead will occur for such research projects. IRB application, subject recruitment, etc. can be overwhelming and even scary to many of our computer science students. Third, I'm not really sure whether my decision to develop our own hardware sensors was a wise decision. Let's evaluate. We use the Pareto Principle, or the so-called 80-20 principle, as a framework to evaluate the success or failure. The 80-20 principle says 80% of our results is from 20% of our effort. Let's put the rank 1 publications as the outcome measure. See what happens. For our Iris project, it is basically a smartphone app. We worked on this project for roughly 1 year. We published a rank 1 paper in 2014 and a follow-up journal paper, and we have even won the first prize of Asian Pacific Assistive Rehabilitative Therapeutic Technology Challenge 2015. I could consider that is the ideal case, is a success story. Now, let's look at our MANA hardware sensors. It cost us 80 years' time, and I have tried very hard to secure roughly $500,000 to support this line of research. Unfortunately, we have produced 0 rank 1 publications. From this point of view, it is a real disaster to have such kind of project. And our productivity dropped. The overhead is immense. Even just to produce a plastic bag, a plastic case for our sensor cost me a lot of time and resource. It is almost nature to stop this effort because it is not necessarily the best use of my time. And of course, this kind of evaluation is too gloomy. Therefore, I would like to actually evaluate this project from a different perspective. Let's put the personal growth as the outcome measure. This picture looks much brighter. We consider the important concept called a growth mindset. The first outcome that is very positive, we graduated 2 PhD students in time and 5 FIP students worked on this project. We built hardware, software, algorithms. We honed our communication skills teamwork, collaboration, leadership, and resilience. We produced papers, not necessarily rank one, and one patent, one MVP. And my former student and current colleague, Dr. Boyd Anderson, even set up a startup company, Solarmetrics, capitalizing our team's multi-year research effort. I myself also benefit. This research helped me to be a more comfortable teacher to teach CG 4002, a course in our computer engineering program. I was even made a co-chair of the Joint Academic Committee, which runs our computer engineering program. In short, this unique journey has significantly broadened our horizon and allowed us to experience pain, but also see bigger pictures and connections. I would like to thank my students, collaborators, and funders who enabled this exploration. These are my students I'm very proud of. And even more positive news is two couple of them not only finished their PhD thesis in the lab, but also get married happily. Now, I would like to also thank my collaborators, including Professor Schlock from Harvard Medical School, Professor Wang Jian from Huashan Hospital in Shanghai, and Dr. Ng, Dr. Tang from Singapore General Hospital. Last but not least is my colleague, Professor Hugh Anderson, and without his encouragement, I probably would not dare to venture to the hardware business. Finally, my founders, including Nokia in Finland, SMUL in the United States, Ministry of Education in Singapore, A-STAR, and the National Research Foundation, also in Singapore. No fund, typically no fund. The pandemic gave me a natural breakpoint to reflect. What is the challenges in this direction? First, technology. Assessment of mobility and speech requires a lot of data. Data collection and annotation are challenging, expensive, and lengthy. Clinical collaborators, they must have not only passion, but also time, which they typically don't. Passion alone is necessary, but insufficient. And the pandemic brought all of our clinical experiments to a standstill. That is not very nice. What can we do next? So this is still our hut. Let me move on to the second line of application, what we are trying to work on. Instead of helping Parkinson's disease patients, we develop also sound and music computing technology to help people like myself. Here is a true story, which motivated me to start a new research theme in the lab. This is an anonymous student feedback before my tenure. He complains about my oral English. Very frankly, I took this comment as an insult initially, but later on, I realized his comments or her comments was very sensible. It helped me to identify not only my own weakness in English, but also an immensely important societal need, a pain that billions of language learners suffer. They all desire good solution, which is a great opportunity for my lab. In the past 3 days, you have listened to so many research talks. Are you tired? If yes, why? Let me try to analyze this phenomenon from a Shannon information theoretical point of view. This represents the speaker, the source of the communication system. This is the channel. In our case, is a Zoom. This is the decoder or the sink. That's you, the listener. For this communication system, the quality of signal is essential. The speaker should really keep the entropy or the uncertainty as low as possible to ensure the accurate decoding of your message. Conversely, bad pronunciation makes it a very difficult task. In other words, if your clarity is up, the pain of the listener is going to drop. I assume that you will be much less tired if every presenter spoke crystal clear English like a TV broadcaster or Dr. Rob Ellis, my former postdoc, making the listening a more pleasant experience. This expectation might be a bit too high from the listeners. Nevertheless, it is worthwhile for the speakers to be considerate enough from the listener's standpoint and to make at least the effort. Thanks to this anonymous student's feedback, I made some serious effort to improve my English. Of course, I still have a lot of room to improve. While launching a number of research projects to address this important problem. Hopefully, I have convinced you good pronunciation is crucial for effective communications. Now let me move on to our new research theme, sound and music computing, to transform language learning from the rote learning to engaging, joyful, and effective learning. We have developed the world's first karaoke app, S-Lines, for language learning. S-Lines stands for singing and listening to improve our natural speaking. But of course, our karaoke app is much safer in comparison to the ones in the KTVs. The research problem that we tried to address include the analysis of lyric complexity, singing voice intelligibility, singing to text transcription, and build S-Lines karaoke app for language learning. In this journey, we have also encountered multiple interesting research communities like ISMIR, Interspeech, ICASP, and AC Multimedia. My students, FIT students, Wang Riwu, developed this S-Lines app, and he even received the NUS Outstanding Undergraduate Researcher Prize 2 years ago. We continued this journey by developing S-Lines Kids, an AI-enabled smartphone app for primary school kids to learn Mandarin, developed during the pandemic. My FIP student, Xingler, worked on this project and received the SOC Outstanding Computing Project Prize last year. And my FIP student, Ronald, also received the same prize this year by working on this project. So based on my experience, our undergraduate students are entirely capable of doing quality research as long as they are inspired to do and motivated to do. These illustrate the interface design for our system, which includes a mobile phone app for students and a web app for teachers. This is the back-end architecture. This is our preliminary experimental results. To talk about this line of research, I must mention the second research community I encountered on the journey, which is APSIPA, Asia Pacific Signal and Information Processing Association. It was a new community to me. In 2013, I was invited to contribute a paper there, and that's why we have created the world first phonetically annotated, paired song and spoken lyrics dataset, which is widely used in both speech and music research community nowadays for various machine learning tasks. And APSIPA is not really a ranked conference here locally, but this particular paper has received much higher citations than most of my rank farm papers. This line of research on speech and singing voice eventually qualified me also to become a APSIPA distinguished lecturer, although I speak broken English. So I must say, data collection, especially the annotation, is real a pain. I was fortunate enough to recruit a talented student from Harvard University, Sam. He helped me to collect the dataset and annotated every phoneme in this dataset. Here is 2 examples of the sample of the data there.
Edelweiss, Edelweiss, every morning you greet me.
Sorry.
Edelweiss, Edelweiss, every morning you greet me.
And it's very interesting to compare speech and singing. This year, my very considerate PhD student Heng Guan wanted to reduce my pain of data annotation by proposing a generalized unsupervised learning approach to estimate the timing of an event, such as phoneme. So this paper was published in ICML 2021, less than 2 weeks ago. Of course, I care about the mispronunciation detection in speech and singing for computer-assisted language learning. We recorded the voice in this format and also associated videos to do this research task. If our project is successful, the impact is enormous. We could reduce the misunderstanding between people. We could increase the understanding and even friendship between people. This could contribute to a more peaceful world. Now, let me introduce our recent multidisciplinary research project, AI lyricists, generating music and vocabulary-constrained lyrics. My PhD student Stan did a practice talk last week. Some of you may have attended his talk already. This paper will be presented in this year's AC Multimedia. So this is the block diagram I gave him last year. He managed to produce a block diagram 10 times more complex than this one last week, and then the functionality of his block diagram is exactly the same as this one. We have an amazing research team consisted of Professor Kang Ming Yan, a natural language processing person, and Professor Li Wei Sun, a machine learning expert, and Professor Rebecca Starr, who is a linguist. We even managed to secure a MOE Tier 2 grant with PhD scholarship and postdoctoral research fellowship available. Now, its final piece of my talk today is about advice based on neuroscience-inspired and deep learning-based educational model. This model took me 19 years of deep learning to come up, expressed in this equation. which describes a system from input to output. The input is our fresh students, and the output is our graduates. The system in between is the environment we provide to them. I would like to say our students here are generally too hardworking, but hardworking has a limit. Therefore, I increasingly kind of focusing on the smart working, leveraging on neuroscience. Frankly, I'm so happy to be involved in the entire process of education in NUS, from selecting the right students to helping students to find a suitable position. Before I got tenured, my main focus is on publishing rank 1 papers. But after tenure, in the past 10 years, I had the luxury to actually see a bigger picture. I was in the SOC Graduate Admission Committee, as well as in the ISEP Admission Committee, to help us select the right students, who is intelligent, imaginary, and with initiative. We hope to recruit students who have the curiosity and a desire to learn. And we hope to provide the right environment for them to learn. In fact, this formula was developed for my own students in the lab, but I believe this formula could be generalized to the entire university. And as the outcome, we hope to nurture happy and successful graduates who have the habit of lifetime learning. Of course, for this model, we have to evaluate its effectiveness. We have done some experiments. These are the results. I've graduated 9 PhD students, 2 become faculty members or postdoc, 5 become industry R&D leaders, and also 2 become entrepreneurs. My master's students and bachelor students were pretty successful as well. The 3 FIP students I supervised in the past 3 years all got A+ and with awards. And I'm very proud of my 2 recent PhD students who graduated in the past 2 years' time, who received the investment from NUS GRIP program. Each of them received $100K to start their deep tech startups, effectively turning their PhD thesis to commercial products. Of course, it is not nice to only talk about money. I'm also equally proud of my other students. For example, Aaron Shinoy, who became Singapore's first Grammy-nominated music producer. That's a great achievement. In conclusion, the deep learning-based model makes me a more qualified educator now. I'm pretty proud of that. Finally, some advice to our students and colleagues. Many of our NUS students tend to be too hardworking. To the level, our school created a special job for me to monitor. And if our students want to take more modules than they are allowed to do, they have to write to me and to justify how they can manage without burning out. I happily did this job since 2013. According to my educational model, our students should really focus more on smart working rather than hard working. Take good care of your brain, which is a very delicate organ. Don't abuse it. Because if this biological neural network in your brain is broken, you hardly have any chance to repair it. Unlike your broken car, you can simply get it repaired. I consider a research journey such as a PhD program a marathon rather than a 100-meter competition. How can you make your research career sustainable while maintaining a healthy and a happy life? Here are the four key ingredients from the neuroscience perspective: diet, sleep, exercise, and social interaction. Speech and music can play a key role here, and sound and music computing is therefore important. Now let me touch about the topic of breadth and depth, because in NUS, we are converting some of the faculties to new colleges to increase the breadth of our students' knowledge base. I model this breadth and depth idea using a Gaussian distribution with one important parameter, sigma here, which stands for the standard deviation. I would suggest that our undergraduate students definitely should have the breadth. Broaden your horizon. But our PhD students should apply the Dijkstra algorithms to focus on your topic and get your degree done. And our junior colleagues also apply the Dijkstra algorithms to get your PhD done. These represent my own journey, also use a Gaussian distribution. I must say my undergraduate degree and my PhD degree are fairly narrow. It was quite painful for me to do the relearn and refocus. I actually used all of my sabbatical as a re-education program to learn to make myself more qualified for this job. I think I succeeded to some degree. This is a geographic representation of my journey towards lifetime learning, towards multidisciplinary research. I could also say this is the geographic signature following my Chinese professor's advice. For the benefit of those of you who don't understand Chinese, I translated this into English. He advised me to read 1,000 books, travel 10,000 miles, make friends in many countries and disciplines, and finally succeed in having a positive impact on mankind. The last piece of advice is really difficult to achieve. This is exactly why I have traveled almost the entire world to search for my destination and answer. This is a major effort in the past 10 years. I think I've found it. The research I've done in the past years is actually towards this direction. But I have to say, this journey is tough. It consists of 90% of the pain and only 10% of the joy. Do you like to do that? It's up to you. In conclusion of my talk today, I've produced less rank 1 papers in the past 10 years than the previous 9 years before my tenure in NUS. But I believe I've done research which is much more meaningful to myself, to my students, and to the society. With the lessons learned in the past decade, I'm confident that we can do better in our future research with more scientific and society impact. Thank you very much for your time. Any questions?
Is there any questions for Professor Wang?
Hello, Guojia, can you hear me?
Yeah, I can hear you.
Okay, thank you for hosting the last talk that I just gave. Let me first answer a conflict of interest question
The question is, why did you do an advertisement for Solometrics during your keynotes? Are you a shareholder of the company? My answer is, I did it as a gesture of goodwill towards my former student and a current colleague, Boyd Anderson, in the department. But I don't have any share of the company, and Boyd owns the company 100%. So my job, actually, as I explained during my keynotes, was to secure roughly $500,000 to support my students to do the research and to complete their PhD thesis. But in terms of how to actually make money out of this technology, Boyd is 100 times better than me. So he no longer needs my advice in this front. So I have nothing to do with this company, and that I hope answered your question. So any other questions?
Okay, thank you, Paul. We have a question in the chat box.
Okay, I'm sorry, and I actually can hardly hear you. Can you speak clearly? Oh, there is a question here and in the chat box.
Yeah.
Okay. Yeah. Thanks for the interesting and the musical talk. And, it's okay. And a slight non-technical question. You mentioned that after tenure, the variety of your research increased and you begin looking at the intersection of the different fields. And naturally, a lot of students watching this talk now, myself included, are pretty far away from tenure. In terms of what we can do right now, are there any particular insights you would share regarding seeking out of our interdisciplinary research? I must confess, and before my tenure, I talked with a few of our senior colleagues. Many of them told me, interdisciplinary research sounds sexy, but dangerous. And it could be actually a career suicide. So I was pretty careful before my tenure. For our PhD students, I would like to say, from my observation, you have to be really clear what you are good at, what you are really talented at. I give you some example. Some of my students, they are very good programmers, they are very good computer scientists, but in the same time, they are professional musicians. Therefore, we can design a project particularly suitable for this student. I give you two examples. My current PhD student, Stan, he did this AI lyricist project single-handedly. He's the only student to get the entire project done. I think that is a perfect example of multidisciplinary research. And the other project he did is music RX, generating music for healthcare, for rehabilitation. He also did a very nice job. And the unfortunate thing is that the current pandemic put our clinical experiment on hold. We have to wait until we are allowed to do so. I don't know whether this answered your question. So you have to really kind of consider your natural talents and natural strengths and combine them naturally. So this is the example that I just gave you about my student Stan. He's a professional musician. He's a computer scientist. Therefore, he can do this kind of project that I designed for him. Otherwise, it could be very difficult. If you don't understand anything about music theory, for example, it's an impossible task, regardless how hard you work on. Have I answered your question? It's the Kiran, right? Okay, and I would suggest that, can you guys please switch on your video so that I can see you and who are there and then to hear my talk. Okay, thank you very much. Okay, and feel free to shout out your questions. And then, in fact, I do have difficulties to read this text. I'm getting old.
Hello, Professor Wang.
Yes, who is that?
Oh, I'm Oulong Shen.
Oh, okay.
Oh, Thank you so much for the talk and your advice. I feel probably not true. I feel that there seem to be not so much commercial applications and opportunity of music computing compared to computer vision, NLP, and speech processing. And this leads to not as many career opportunities as other AI-related topics. So what do you think is the future prospect of music computing? I'm not sure if it's worthwhile to dig into this area during my master's study.
Great question. Thank you. In fact, this is, of course, an important question. It is related to your future career. My answer to this question is, are you a musician, by the way?
Well, yes.
You are, okay. So I would like to say, follow your own heart. And in terms of career in music, there are also a lot of kind of career possibilities, including become a professor like myself, and then if you graduate, maybe and you can replace me. Okay, that is one thing. Two, there are also a lot of industry jobs which requires a PhD level kind of research capabilities. A lot of companies, they approach me to ask whether I have students to come to recommend. Unfortunately, I don't have so many. And for example, even in Singapore, we do have a company called Creative. Have you heard of that?
Well, not yet.
Okay, that is a music industry and is a industry leader. Another thing, and you know, and we have many big companies like Tencent in China and Google's in the United States, and then all of them actually have department doing music-related research. Okay.
Oh, that's great.
Yeah, I don't think that, you know, method-wise, if you do this kind of research, and you can actually do a transfer learning to do something else as well.
Yeah.
Am I right?
Okay.
And I also agree with you that speech is very important. That's why we do actually research in the middle. Singing voice is a different version of speech. And if you can actually process singing voice very well, and you should have no problem to process speech, because singing voice is so much more complicated than speech. Am I right?
Yes. Yeah.
So technology-wise, I don't see any problems here. And a lot of people in the Izmir community have very successful careers. Even some of the professors actually changed job and from professor to industry, like my old friend and in Columbia University. And he quit his tenured full professor to work for Google. Can you believe that?
Wow, it's amazing.
Yeah, so I don't think that you should be too worried about this. And the key thing is to find your true passion. If you just follow others, and in fact, one of my students in class, she did very well in my class, but she simply kind of has a disillusion about the deep learning. And I said, well, and if you don't believe that, you don't have to follow the trends. Yeah, that's my answer. And there seems to be there are also questions in the chat box.
Oh,
okay.
Well, can I say something more?
Yes, please.
Okay. In fact, I'm really enthusiastic about this field. I have done some research on automatic music transcription for my undergraduate study, and I get some good results. I want to continue this research or relevant topics in my master's period. So I'm so excited to see your group has made so much progress in this field. I'm wondering if your lab has some positions for master's students, or would you like to guide us on some master's thesis?
I'm happy to help you to get your work published if you need any help, if you need any advice. So I'm actually sitting most of the time in my office. Right now, I'm sitting in the office, you see?
Yeah.
Yeah. So don't worry, and send an email to me, and I'm happy to talk to you.
Okay, thank you so much.
You're welcome.
Hi, Prof. Can I ask you a question?
Yes, please.
Oh, okay. So, Prof, first, thank you very much for the impressive presentation. It's actually amazing to see that music computing can actually be applied in various fields like clinics and education. But could you please elaborate more on whether our work has been applied in reality? Like, has the application for Parkinson patients be applied in any hospitals, or the language learning apps, the Slimes Kit app, has been applied in any educational institutes? And how are we measuring our impact in real life? Thanks.
Thank you very much, and Yusung, for this great question. As I said, this line of research, I have faith in it. So the first line of research about the AI-generated music for rehabilitation, right? There are 3 hospitals. They are actually searching us or chasing us to collaborate with them. One is our own hospital, National University of Singapore, and the other one is Shenzhen Second People's Hospital, which is a very established hospital in Shenzhen in southern China. And another hospital is the National Taiwan University's teaching hospital in Taipei. And for some reason, they read my paper. They got really kind of amazed what we can do. And I said, well, and after this pandemic is over, I'm very happy to collaborate with these clinicians, because before that, I have to beg the clinicians to collaborate with us. Now they are actually chasing us. That's a very positive sign. And then, as you can see from our experiment and the demonstration, we did test this technology with real patients, but not yet finished the clinical trial. And the second question is about the language learning. As you can see, and I still struggle to, you took my class, right? I still struggle to give lectures in English, but I'm doing much better than actually 10 years before. My, I got my tenure 10 years ago, almost exactly 10 years ago. So I'm making progress. But about this line of research, definitely there are huge possibility and potential here. We already tested this, our technology, in Yunnan Primary School in Singapore, and they were very positive about our technology. And my dream is that every primary school in Singapore and should use our technology. That is my dream, and we are pushing towards that direction. And in fact, one of the officials from Ministry of Education just visited us a few weeks ago. So I'm going to talk with them more on how to incorporate our technology there. But I must say one thing about this language learning app. This is really a personal problem. And when I received this student feedback about my oral English, and I was really kind of feel pity for myself. Why is that? I really tried my best. I never had a chance to learn any English before I enrolled into university. Can you believe that? And then from the neuroscience perspective, I already lost the so-called golden window to learn a new language. Regardless of how hard I try, I will never achieve the proficiency like our colleagues and in the department from the United States. And then, and that's just a missed opportunity. And then also, as you know, and I did my master's degree in Germany in German. And I finished my PhD in Finland. And although I managed to write my PhD thesis in English, but most of my colleagues in Finland speak Finnish language. That's also not the ideal kind of language environment. So that's why I'm very passionate to develop our technology to help more people. And even including our own students in NUS. Right now, I have one project with our English teacher, another project with our Korean teacher, and the third project is about with our Chinese, English, and Korean. 3 teachers are collaborating with us right now. So definitely you can see our technology is going to directly benefit our NUS community. I hope that I answered your question.
Yes, sure. That answers my question. Thanks, Prof. And actually, I have an additional question about, like you mentioned that under the current situation that COVID-19 has blocked our clinical trials and some experiments at school, what are our plans to push on these projects? And more specifically, do we have future directions or ideas for the new versions for these apps?
Yes, very clearly. At this moment, what I'm trying to do is to actually get our technology out to our NUS students' hands first. So this makes our data collection much easier. So because I have the collaborator who are teaching their language class anyway. So the language assessment they have to do every semester, multiple times. So that's a natural source of data that we can do. And then also our students and like yourself, and is going to work as a FIP project. And I do hope that your project will be useful to people. So I really don't like to work on something that I don't see any use. That's why you can see that even music technology or sound and music computing, many people consider that is something, yes, nice to have and not essential. But as long as our technology can help the patients to recover and at their comfortable home, as long as our technology can help people to improve their effectiveness in learning a new language, then that is a value. We must provide scientific evidence how much our technology has improved. And we do have some evidence here.
Okay, thanks, Prof.
You're welcome. Any other questions? So don't be shy. And then if you are too tired, as I said, and why you are tired, and after 3 days of intensive seminar here, of course, everybody is tired. And then, you know, I also shared you this Shannon information theoretical framework to explain why you are tired. Are you convinced? That's my question. So if you allow me, I can share my slides here. Okay?
Okay.
Yes. I cannot start screen share. Can you allow me to share my slides? So I do have something important to say.
Okay, can you try now?
All right. Share. Oh, that's great. Now I can share my slides. Okay. So one thing. So which slides? Okay. So what I wanted to share with you guys. Oh, this is the slides I wanted to share. Can you see that?
No,
Oh,
it's empty.
It's empty. All right. Why? Oh, okay. This is interesting. Why is that not work? I'm sorry, I'm not so good with this stupid Zoom. I so much prefer actually face-to-face lecture. Okay, this is the slides I wanted to share. Okay, this is the one. Very nice. So this is a new theory. And, you know, that's why I so much like these people, like this narrator and Dr. Rob Ellis, and he is my former postdoc, and he speaks perfect English. In fact, this is one of the important reasons why I recruited him from Harvard Medical School to Singapore. And he is a nice researcher, and then he helped me also to improve my oral English. And as you can hear from the video, he speaks very, very clearly. And then this reduces your workload to decode the message. But on the other hand, for example, my spoken English is not that great. So your decoder has to work harder to understand what I'm talking about. So has anybody any problems to decode what I wanted to say?
Yeah, I think we have no problem.
Okay, so that means I made some progress. And then another important slide I wanted to say, because I missed something. This one. This is actually the educational model. In fact, this equation has two different interpretations. And as the output, right, we want our students to be successful and to be able to produce more papers, right? And more patents and more products, even a PhD degree, right? So we have N times P's here. But this equation has a second interpretation, is that educating a freshman student to a happy and successful graduate is the NP hard problem. So every educator has to work harder. So how to actually bring our students to have a really successful research career here. So that is the key message I wanted to say. And, you know, and in the university, I think one suggestion I would like to give you guys is that university professor is one of the best jobs in the world, believe it or not, because you have the freedom to do what you love to do. But this is not true if you work in the industry. I worked in Nokia Research Center for 9 years, and I do know that is a true story. Okay.
I see. Thanks for the sort of insightful look into this. I think we're starting to get near our closing session time, so
okay.
We might need to move on. But once again, thank you, Professor Wang, for that detailed insight.
All right. For any of you who have additional questions, I'm right now sitting in AS6 and level 4, and feel free to drop by and to send me an email. Okay. So thank you very much for having me to give the last talk.
Thanks again.
Okay. So then I probably could